A spring of spring constant K is separated in two parts in the ratio 3:1. Two segments of spring is attached to a mass M and the mass is made to execute in simple harmonic motion with small horizontal oscillations as shown in the figure.
Right, our first equation. There are two methods that we can use to connect springs, series and parallel. In series method, when we have springs K1 and K2, so we add them 1 over K1 plus 1 over K2 equals 1 over K. Here 1 over K, here K is the combined spring, and here when it is connected in parallel, so K equals K1 plus K2. You should know that equation, right? Then here they are telling that the spring is separated into the ratio 3:1 ratio. So that means there's one spring and it is divided into 3:1 ratio. That means 3 parts and 1 part here, right? Say now the initial spring constant is K. That means it is separated into 4 parts. So altogether, say now this is K1, K1, K1 and K1. So when we add them together, the final value has to be K. So that means let's add them like K1 plus K1 plus K1 plus K1 equals 1 over K. So common denominator is K1, 1 plus 1 plus 1, 4 equals 1 over K. So you can see now K1 equals 4K, right? So one spring will be now 4K. So when three of them are together, again in series, again we have to add in series method. So here we are getting answer, this new K1, K dash let's say, is equal to 4K is common. So here 3, K dash equals 4K over 3, right? So we have two springs now, 4K over 3 and one separate spring 4K, right? So if we get into the equation, here this spring 3K over 4 and here this one 4K. Let's check whether our answers are correct. 4K over 3, my bad. So this has to be 4K over 3, right? Now this combined springs, now you can see these two are connected in series method. Apparently it might look like series method, but this is actually parallel because it is connected, see now here, from this part and this part separately. That means if springs are connected in series, that means the springs are connected in series. Now you can see the springs are not connected. This K1 spring and K double dash spring is not connected together. So that means these two are parallel. So we can directly add the spring constant. So 4K over 3 plus 4K. So we are getting 3 common denominator 16K. Now let's apply it to the t equals 2 pi root m over k equation. So 2 pi root m over k. So final k is 16K over 3. So simplified furthermore, 3 goes up, 3m over 16K. So we can take the root value of 16. So 2 pi over 4 root 3m over k. If you simplify it furthermore, now you can see the answer becomes pi over 2. So pi over 2 root 3m over k. So it's the fourth answer. Alright students, if you think this is valuable, share it with your friends, study together and win together.